Right now, a 15-year-old is launching a SaaS platform over a weekend. Designers with zero traditional engineering background are deploying full-stack databases. They are using AI coding assistants to turn basic ideas into complex software architectures in a matter of hours. Single developers are pushing out production-ready features in 48 hours. That exact same output used to require a 5-person engineering team and 3 months of sprint cycles. But an AI assistant only sees the immediate code file you ask it to write. It has absolutely zero context about the real-world environment where that code will eventually run. Because of that missing context, the AI leaves behind very specific, predictable blind spots. It will happily write a functional admin panel and entirely omit the authentication check, or hallucinate a database endpoint with public access enabled, simply because the tutorial it learned from told it to do so. The speed of building has completely outpaced standard structural safety. Underneath sleek, fully functional user interfaces, developers are unknowingly deploying highly vulnerable code. To see what that vulnerability looks like in the wild, we can look at the forensic results of a single automated security scan running through recent GitHub commits on a random Tuesday night. This animated timeline maps that exact scan. In hours, the system flagged 32 live production keys leaking. If scraped, a script can automatically spin up massive crypto mining servers. The developer wakes up 8 hours later to a $40,000 bill. Corporate engineering teams catch these mistakes using massive security pipelines that cost tens of thousands of dollars a year and require a chief information security officer to configure. These leaks aren't the result of enterprise failures. They happen because solo builders are operating at lightning speed, without a safety net designed for the code they're generating. That specific gap is exactly why Lictor-Ai exists. It is an open-source interceptor built entirely to hunt down the exact shapes of bugs that AI assistants leave behind. Looking at Lictor's architecture, we see a completely closed loop, a local-only tool with zero telemetry. The code and scans never leave your machine. There's no external dashboard. Lictor embeds directly into environments solo builders use, attaching to IDEs via the Model Context Protocol. Once installed, audits run under 60 seconds, running 7 specific AI-tuned checks, and it is entirely free. Before a mistake even makes it online, a single-line pre-commit hook acts as a preemptive defense. It catches the exposed Stripe key while it's still sitting in your local environment, completely blocking it from being staged or pushed to GitHub. It functions silently as an automated security team, living natively inside the tools you already use to build. Most security scanners operate as opaque black boxes. Code goes in and vague warnings come out. Lictor replaces that with a transparent crew of 11 specialized readable agents. One agent, named Hawk, operates entirely as a pattern scout. Trained on over 1,400 real-world audits, it actively hunts for the exact hallucinations and omitted policies that AI assistants frequently write. When an issue is found, a designer agent named B drafts the smallest possible fix. Instead of generating a 40-page remediation guide, it pinpoints the exact file and line number required to patch the vulnerability. But the most critical step is the translation protocol run by the Lyrebird agent. It aggressively strips away CVSS severity scores, CVE tracker numbers, and corporate security jargon. A traditional scanner will generate a dense wall of warning codes, labeling an issue as an information disclosure vulnerability. The Lyrebird protocol translates that into a single, actionable sentence. Anyone can read your customer list. Lictor prioritizes plain English as the primary interface, enabling non-technical founders to understand and secure their own platforms without a security consultant. That localized protection only covers the building phase. Eventually, the application goes live, connects to external APIs, and starts handling real user data. For deployed projects, Lictor Shield operates as a browser extension. It actively scans live URLs to detect hard-coded API keys and exposed databases before a user even creates an account. If the deployed application relies on external models, a runtime interceptor called Sentinel steps in. As data flows out, it isolates and blocks prompt injection attacks. The filtered data is instantly converted into standardized anonymous 16-character fingerprints. The result is an unbroken chain of defensive scaling. It protects the very first line of AI-generated code on your laptop, all the way through to the application's first live interaction with a customer. In an era where a solo developer can deploy a massive infrastructure in an afternoon, security trust can't rely on expensive enterprise certificates. It has to come from verifiable open-source code that anyone can read and audit. That is the philosophy driving Lictor. It was built from a stubborn refusal to let independent builders watch their projects get destroyed by entirely preventable mistakes. There is no hidden commercial trap waiting at the end. There is no telemetry collecting your data, no planned pivot to a paid SaaS model, and no paywall blocking the essential features. If you are using an AI assistant to build software right now, you need to open your terminal and install the pre-commit hook tonight. Generating complex software through conversation allows anyone with an idea to compete with established engineering teams. Ship fast and code freely. Just make sure you don't ship your keys with it.